Alright, so now that we've figured out how rational tangles operate, and we've found really a complete invariant for rational tangles in the tangle number, the fraction, the continued fraction representation of a tangle, now our job is to bring all of that back into studying knots. So the questions we want to look at next are, how do we come up with numerical invariants not for rational tangles, but for knots that can capture enough information about the knots to tell us something interesting? And we're going to start by figuring out how we can directly take what we know about rational tangles and connect it back to build an invariant, or at least a notation to tabulate knots. But then ultimately we want to try to push that a little bit further and think about other ways that we can associate a number, a numerical invariant, to knots in a way that doesn't depend on the diagram or the projection that we draw for a knot, but which only depends on the topological type of the knot itself. So what numerical invariants can we find that work for knots? So the plan is, first of all, to determine whether or not the fraction of a rational tangle, so the fraction that we learned in our previous set of videos, actually gives us a numerical invariant that works for knots that are related to rational tangles, that we call rational knots. Second is we're going to push that a little bit further and look at a different numerical way of tabulating knots called Dowker's notation, which is really just a direct way to look at the crossings that are present in a knot diagram and just sort of tabulate them so that we know which strand is crossing which strand. Now we're going to push that a little bit further and study, first of all, if we're going to come up with classifications for knots, what are the basic building blocks, the bits and pieces that make up all knots. So those are going to be called the prime knots. So we'll look at how we classify knots as prime or composite. And then the final objective that we have here is to look at three different other numerical invariants for knots. And these are going to be numerical invariants in the sense that they give us a number, actually it's just going to be a positive whole number in these cases, that doesn't depend upon the diagram that we draw for a knot, but which only depends upon the topological type of the knot itself. What these numbers won't be is they won't be complete invariants in the way that the tangle number was for rational tangles. In other words, we won't be able to always reconstruct a knot given one of these numerical invariants that we learned for knots today. We're going to need more high-powered stuff in order to get complete invariants for knots. And so after we talk about numerical invariants, we then want to start pushing towards invariants for knots which have more algebraic structure, such as groups and polynomials. But for now, we're going to get the ball rolling with these numerical invariants.